Let's take a look at measures of variation and see why it matters. This is an example that I took from the textbook, and then I'll look at another one that might drive this home a little better. But it says to consider the weighting lines for Big Bank and for Best Bank. Big Bank has 3 weighting lines, Best Bank has 1, and so we have some wait times. Fortunately for us, these are in numerical order, so we don't have to do any rearranging if we're asked to find the median, which we are. We actually want to take those 2 banks and find both the mean and the median. So take a second and do that. So when you do the math, you find out that both data sets have the same median and the same mean. So given those 2 data sets, if I was just looking at their measures of central tendency, they are the exact same. So then we may want to consider another value for this data set, which is called variation, because at this point, if you just told someone this information, then they would say, well, it's no different if I'm a freak about having to make sure that I'm in a hurry and I want to get out of the bank really fast. Which bank would be the best one? Okay, I wouldn't know which bank would have the better waiting times if I just based my information or my decision off of the mean or the median. So we're going to consider variation. So if you look at these 2 data sets, variation means or refers to the spread of the data. So if I look at this first data set, the lowest number is 4.1 and the highest number is 11.0. Compare that to this data set with a lower value of 6.6 and an upper value of 7.8. Can you just, by looking at the data, tell which one has a larger spread or more variation in the data? Clearly, this first one has a higher variation. This one has a lower variation. And remember, variation refers to the spread of the data. There's more spread in the first data set, less in the second. Okay, so the one that has the most variation would be Big Bank. We take a look at their histograms. Okay, we put waiting time here on the x-axis, frequency, number of people that waited, that time on the y-axis. We can clearly see with this graph, look at the spread of the data here as opposed to the spread of the data there. So this one has a larger spread, which means it has a larger variation. Knowing the spread of your distribution can help you make a decision. Let's think about this situation. You're in the market for a car and you're really interested in finding out what is the longevity of the transmission in that particular vehicle. So you look up some data and you find that car A that you're looking at has a mean transmission life of, let's say, 10 years. And car B has a mean transition life of 10 years. Well, based on that data, you could pick either car and think that you would that there would be no difference in your decision. But suppose we were given the spread of that data. Let's say car A, the transmissions can last as low as 2 years or as high as 15 years. And you do a little more investigation and you find that car B, its transmission has a life of approximately 7 years to 18 years. So this is our spread or variation. If I knew this information with respect to the car I was trying to to purchase, and the lifespan of the transmission was very important to me, I don't think I would choose A, because I run the possibility of having that transmission last only 2 years. For B, the least it would last is 7, and the most it would last would be 18. This, to me, given that data, given that spread, would help me make a better decision. So if we base our decisions on the mean alone, we could be misled. So one measure of variation is to determine the range of the data. And all that is the difference between the highest and the lowest value. So if I went back to, let's say, Big Bank, let's look at those two, Big Bank and Best Bank. For Big Bank, the range would be 11 minus 4.1. And the range for Best Bank would be 7.8 minus 6.6. Oops. So notice that the range of values for Big Bank is 6.9, and the range of values for Best Bank is 1.2, and these are minutes because the waiting time was in terms of minutes. So at Big Bank, you could wait in line a maximum of 11 minutes and a minimum of 4.1 minutes. Here at Best Bank, you could wait a maximum of 7.8 or a minimum of 6.6, and so that variation, when it's small, says there's a little more consistency, in this case, in the wait times. So that's one measure of variation. Over here, if I looked at the transmissions, the variation here would be 15 minus 2, so the variation would, or the range, excuse me, the range would be 13 years. The range here would be 11 years. So it's just the difference between the highest and the lowest value. Real easy to calculate. Then we have these other values we're going to calculate. Something called the lower quartile, the middle quartile, and the upper quartile. Now the middle quartile is just the median of your data. We know how to find the median. We just look at that value that occurs smack dab in the middle. So the median is easy to find. It's just that middle piece of data. What do we do if we have two pieces of data that occur in the middle? Do you remember? You add them up and divide by 2, if that's the case. Okay, so that's how we'll find the middle quartile. Now the lower quartile is just the median of the lower half of the data set. So it's just finding, again, the middle value, but it's the lower half of the data set. And the upper quartile is the median of the upper half of the data set. So when we have a data set, that median value right here is called our middle quartile. And when we go to find the lower quartile, we look at the lower values here, and we find the median of the lower values, and that's called the lower quartile. So this is our middle quartile. The middle of the lower values is called our lower quartile. So if I look at this data set, the values here below the median are 4.1, 5.2, 5.6, 6.2, 6.7. I think that looks like. It's kind of hard. Here we go. Now I can see a little bit better. Okay, so the middle, 1, 2, 3, 4, 5. I have 5 pieces of data, so the one right in the middle would be 5.6. That would be my lower quartile. For the upper quartile, we go to the upper end of the data set, and we find that middle value. So here on the upper end, I have 1, 2, 3, 4, 5 data values. So the one right there in the middle would be the 8.5. That would be called my upper quartile. I'm going to be consistent with my colors here. So now do the same thing for the data set below. Find the lower quartile, find the upper quartile. It's easy enough. It's the piece in the middle. So for the lower quartile, the value would be 6.7. For the upper quartile, the value would be 7.7. So these quartile values are really easy to find. It's just the middle. If you can find the median, then you can find the median of the low and the median of the high values. So just like we did earlier here on this sheet, we've got the lower quartiles, we've got the upper quartiles for those two banks with regard to their waiting times, and we have the median. So those are some important values you want to find for a data set. And fortunately for us, again, these were ranked from smallest to largest. That really does help. And that must be done first before you can find any median values. Okay, so there's this 5-number summary that's going to help us in drawing a graphic for a data set. It's called a box and whisker plot, but before we get into that, let's just think about the 5-number summary. Very easy values to find. The lowest value of the data set is your first value, then your lower quartile, then your median, then your upper quartile, then your highest value. That's your 5-number summary. So if I went to Big Bank, actually take a second, write all these values down. Go to both banks and write down a list of those values. So here's the 5-number summary for each of those two banks, their waiting times. This 5-number summary allows us to draw a graphic called a box plot, or sometimes referred to as a box and whisker plot. And when you construct these, there is a box that you're going to draw. And the box is always around these values. So you can have a box around these, and then a whisker that's going to go out to these extreme values. So the box is going to be drawn between the 3 middles, that creates your box, and then these will be your extreme values. So take a look at the box and whiskers below. Now we actually put them on the same axis so you could compare. Normally these are done separately, but just to conserve space, we have the box and whisker plot for Big Bank and the box and whisker for Best Bank. And all we did was take those 5 numbers, 1, 2, 3, 4, 5, those 5 values, and plotted them on the number line. And so we're just looking at the waiting times, the data values here. And so the 4.1 and the 11.0 were the highs and the lows. These values, the 5.6, the 7.2, and the 8.5 represent the low quartile, the median, and the upper quartile. And those are the values you draw your box around. And then from that box, you're going to draw whiskers to each of those extreme values, your low and your high. So same thing here. We've got the low value, we've got the high value, and then in between, we have the low quartile, the median, and the upper quartile. This is just a great graphic to give someone an overall idea of the variation in the data. Clearly, you can see that this box and whisker has much more variation than this one. So it's just a way to visualize the variation, in this case, of the waiting times between the two banks. So it's a great graphing device. Okay, so that's one measure of the spread of our data. We can see it from the graphing device, and the range, that high minus the low value, is a measure of variation. And here's another mathematical measure that we can calculate, measure of variation, and it's called the standard deviation. You need to know how to do this. This is a very important part of Chapter 6. I think what I'm going to do is stop the video here, and then on 6B Part 2, I will go ahead and show you how to calculate the standard deviation. So I will stop this one here.